Creatine monohydrate's first controlled human trial was published in 1992. The researchers were Roger Harris and Eric Holtman, and they demonstrated that oral creatine supplementation significantly increased muscle creatine content in human subjects. Within 2 years, athletes at the 1992 Barcelona Olympics had begun supplementing it. Within 5 years, it was the most commercially successful sports supplement in history. That was 30 years ago. Every major supplement category has turned over multiple times since then. Protein formulations, pre-workouts, amino acid complexes, hormonal supplements, novel training aids. The list of products that dominated and then declined is long. Creatine monohydrate has not declined. It has grown in application, deepened in evidence, and maintained its position as the most consistently replicated performance supplement in the scientific literature. The reason comes down to what monohydrate actually does and how thoroughly it has been studied. The phosphocreatine system is not a niche mechanism. It is the primary energy buffer for maximal and near maximal effort across virtually every sport and physical activity. Any athlete who does anything explosive, heavy, or repeated at high intensity benefits from having more phosphocreatine available during those efforts. The mechanism is universal, not specific to one training style or one sport. The evidence base that has accumulated over 30 years covers a scope that no alternative form can approach. More than 700 peer-reviewed studies on creatine monohydrate, populations from adolescents to the elderly, applications from strength training to endurance performance to cognitive function to neurological conditions, safety data from populations including patients with kidney disease, who theoretically represent the highest risk group for any supplement that increases creatine metabolism. Every alternative form has been positioned as an improvement on monohydrate. Each has shared the same fate, equivalent or inferior performance in the head-to-head trials that were eventually conducted. The scientific community has not found a form that outperforms monohydrate at equivalent creatine doses in muscle-loading studies because the limiting factor has never been the form of delivery. It has been the creatine transporter in the muscle cell, which operates the same way regardless of how the creatine arrived. Stability is one of monohydrate's underappreciated advantages. In dry powder form, creatine monohydrate is chemically stable for years under normal storage conditions. It does not require refrigeration, special handling, or a limited shelf life. This stability is what has allowed it to scale as a commodity ingredient in global supplement markets at consistently low prices. Cost is where monohydrate's 30-year dominance becomes most practically significant. Commodity production of high-quality creatine monohydrate has driven the price to levels that make daily supplementation accessible to almost anyone with a supplement budget. The infrastructure of testing, quality certification, and supply chain verification built around monohydrate does not exist for alternative forms. The king has compounding advantages that alternative forms cannot replicate by launching a new product. Creatine was actually discovered in 1832 by the French chemist Michel-Eugène Chevreul, who isolated it from meat extract and named it after the Greek word for meat, creus. Its presence in muscle tissue was confirmed throughout the 19th century, and the phosphocreatine form, bound to phosphate and serving as the rapid ATP regeneration system, was characterized in the early 20th century. What took 160 years to follow was the question of whether supplementing dietary creatine above normal intake levels could meaningfully increase muscle stores and improve performance. The 1992 Harris and Holtman study answered that question definitively. Muscle biopsies before and after oral creatine supplementation showed significant increases in total creatine and phosphocreatine content. Within 18 months, Greenhoff, Casey, and colleagues at the University of Nottingham were publishing controlled trials showing improved performance in repeated sprint efforts and resistance exercise. The supplements industry and elite sport adopted creatine faster than almost any other nutritional intervention in history. The 30-year record also delivers something no alternative form can claim: long-term safety data in vulnerable populations. Creatine monohydrate has been studied in patients with pre-existing kidney disease without adverse renal outcomes and given to children with metabolic disorders for years without observed toxicity. No novel form has this history. In supplement science, the combination of strong efficacy evidence and long-term safety data across diverse populations is rarer than it should be.